Good morning. 5.1 Polynomial Functions. Read and highlight. Let's go to work. We've discussed linear and exponential functions already. We saw that linear functions have a constant rate of change, while exponential functions may start off slow but quickly speed up. Now we're going to examine another category of functions known as polynomials. Just as a quick little refresher, just for fun's sake, remember that the graphs of a linear function was a straight line, with a positive slope, a negative slope, no slope, or undefined. But exponential functions, and you guys have only looked at this a little bit, they start off and then they increase way up, okay? Or sometimes they come down, and get really flat, okay? But either way, they are definitely curves and have asymptotes and crazy things like that, okay? So we're not going to be dealing with those. We're going to be dealing specifically with polynomial functions now. Now, polynomial functions, linear functions, are to the first degree, so you don't see any powers or exponents. But polynomial functions, we're going to have exponents, just like we did in exponential functions. Okay, so what is a polynomial? A polynomial in one variable, and those are the ones we're going to focus on now. There are more, okay, but we're going to focus on one variable, is any function with a constant multiplied by a variable to a non-negative, meaning it could be zero, whole number power, or the sum or difference of those things. Wow, that's a long definition. Okay, the constant multiplied by the variable is known as the coefficient. Let's look at some examples. That's probably the best thing that we can do. Okay, examples of polynomials. So here's a polynomial. This polynomial it's got no negative exponent. So that's the first thing that we're looking for. I'm going to go up here and just go to a different color. Let's go red. One variable, that's important. Okay, with a constant. What's a constant? Constant's just a number, right? Just a number. That's all. Another name for a constant. Okay. Multiplied by a variable to a non-negative degree. That's important. That's really, really important. To a non-negative degree, meaning it could be zero. Okay. The whole number power or sum of difference of things. Okay. So basically, I can't have a negative. Okay. So if we look here, no negatives. The second polynomial is a non-negative exponent, including the constant, -7, but it's really -7 to the x to the 0. See, we have to include a variable. That's what it's telling us. But if I said x to the 0 power, what do we already know about anything to the 0 power? Well, that's equal to 1, right? So if I have a variable to the 0 power, I don't actually have to write it down. That'd be like writing 7 times 1, which is 7, okay? And that's going to come around a lot. Okay, so if we just have a constant, we could always write that constant as times x to the 0 power. So a polynomial so far is a combination of numbers and variables, and the variables have to be to non-negative powers. I say non-negative because you could have 0, and 0 is neither negative or positive. All right, so let's look at this last one. -5x. This polynomial has a non-negative exponent. What's the exponent? It's the first. And notice that means the function is officially a polynomial. Okay, so let's look at these ones that are not functions, okay? The square root of x. Why would that be? Well, here's why. This part that I haven't highlighted yet. It's got to be a whole number power. What are you talking about, Coach Herman? Well, remember, we talked about this just ever so slightly. This could be rewritten as x to the 1/2 power. Remember, the top is the exponent, and the bottom is the root, like square root, cube root, fourth root, fifth root. Okay, so this could be written to the x to the 1/2, which means it wouldn't be a whole number power. So not a polynomial. Okay. We also talked about the exponents a little bit this past week, and we learned about negative exponents. Anytime that we have a variable on the bottom, that's the same thing as saying 3x to the negative first power. So, yes, that's correct.
You have that many kids?
Yes, that's it. In the 2 classes.
Okay.
Yep, thank you, dear. So this would be a non-negative exponent because, because it's to the negative 1. Remember, I'm not going to go long into that, but anytime that you're going to move a variable to the other side of the fraction bar, that's a negative exponent. Okay. All right. Well, last one here. That's given us 2 to the x power. Well, it says it has to be to a non-negative whole number power. Well, what is the exponent here? Well, it's x. So what's x? Well, we don't know. And it could be anything. There's no limit. Okay, so this is not a power because the variable itself is a power, meaning exponents, or it's not. So in order to be a polynomial, you got to have numbers and one variable to a non-negative exponent. Okay, if you have anything else, we don't have a polynomial. Okay, moving on. So we could also use a polynomial like this. And I'm not even going to spend any time working on that, but it just means that's crazy. In this form, we can see that each of the a values are coefficients. So each a is a coefficient. And that sub n, that just means that you have some different, okay? Subscriptive notation, meaning the first coefficient second. And then the last term is just a constant because it can be times x to the 0 power. A term in a polynomial is based or separated by an add or subtract sign. That's hugely important. Okay, for example, a to the n, x to the n is a term, and a2, x2 is another term in this polynomial. Why? Because they're separated by addition signs. So those make those separate. Okay. The last thing to notice here is that there are infinite number of terms. Polynomials don't have or can't have infinite terms. There has to be a set number of terms. Okay, there must be a highest exponent value in the polynomial. Okay, all of that's not hugely important, and that's really mathematical. So let's go to the next page. All right, so how do we classify polynomials? Well, first of all, I want to talk about standard form. Okay, we've talked about this a little bit. Standard form means, hey, it's just the way we want it to look. Standard form means get your terms lined up, high to low. Get your terms lined up, make them high to low. Look for a GCF, that's something everyone should know. You heard that before? Yeah. Okay. So if you put them in standard form, you'll be able to see the highest term really easily because it'll be at the beginning, and then your constant will be at the very end. All right, so the highest exponent value is very useful because we classify polynomials by their degree. Booyah. You better highlight this, circle it, bold it. That's how its degree. The highest degree of the polynomial classifies it. In other words, it names it. The degree of the polynomial is equal to the highest exponent. Okay? For example, this polynomial is to the third degree. Oops, get rid of that. This polynomial is to the third degree. Why? Because there's a third degree. Polynomial is the highest power, is the third degree. This polynomial is to the 7th degree. Why? Because its highest power is the 7th power. You might also have noticed that we typically write polynomials in descending order of their exponents. That's called standard form. Certain degrees of polynomials have specific names. In fact, we already know one. A first-degree polynomial is called linear. For our purposes, we'll probably refer to specific names of the first 3 or 4 degrees. Beyond that, we just call it the degree number. So here's a chart. Okay, if it has 0 degree, it's called a constant. We know that because it's not actually even there, right? We don't even have to write it. Okay, something to the first degree is called linear. Notice the exponent is 1 there. Okay, to the second degree, it's called a quadratic. You know, we've talked about that quite a bit. Something to the third degree is called cubic. Something to the fourth degree is called quartic. Something to the fifth degree, I'm going to give you one here. Okay, are you listening? Something to the fifth degree is called quintic. I'm going to see who's been paying attention. Shh, don't tell. Something beyond fifth degree, we don't have any special names that we're going to use, so we would just name it by its degree. So a sixth degree polynomial or a seventh degree polynomial, okay, or an nth degree polynomial. Again, the sixth degree, etc., all they have names, but we won't be referring to them here in Algebra 1. Okay? I am going to use quintic. See who was paying attention. Okay? So, now that we've classified it by its name, now let's classify it by its number of terms. Okay? If it has 1 term, it's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. Beyond that, it's just a polynomial. Okay? Just like the degrees, polynomials with 4 terms and above will be referring to just the first name of a few. Okay? So, we can give it a name by both its degree and number of terms. Okay? Degree first, then number of terms. So this is to the third degree, which makes it cubic, and then it has 1, oops, let me go to a different color. 1, 2 terms. Notice they're separated by that plus. Since it has 2 terms, it's called a binomial. Okay. This is to the third power, makes it cubic, and it only has 1 term, which makes it a monomial. Okay. Next one, see if I can do this a little different way. It is quadratic. Why? Because it's the second degree. It has 1, 2, 3 terms, makes it a trinomial. So we name by its degree and number of terms. So first we look at the highest degree, and if it's in standard form, it should be on the first term. Something to the fourth degree makes it quartic, and it has 1, 2 terms, makes it a quartic binomial. Try the next one. Okay, so it's to the 7th degree, which makes it a 7th degree polynomial, and it's got 1, 2, 3 terms, so it's a 7th degree trinomial. That's not too bad. 5th degree. 5th degree. What's the special name for 5th degree? That's right, quintic. And it has 1, 2, 3, 4. Well, anything above 3 is just a polynomial. Just a polynomial. So, there we are. That is that's what polynomials are and how they are named. Hope that was helpful for you. Have a great day.